Central PA Rock and Mineral Club. We're all here from the Geology Club. All right. Welcome. Thank you all for showing up. That's awesome. What's up, Joe? All right, so this is Professor Steven Lindbergh. He is the man. He knows more than anyone else on earth about everything. I'll tell you. But yeah, he's going to give us a little educational thing because this is an educational quarry. It's not an operational quarry. So we're going to learn about it, and it'll actually give you a lot of idea of where to go, where you want to start, depending on what you want to go look for. So, Steve?
Thanks. Short as possible, like less than 15 minutes, because I know everybody's just dying to get in there and start banging away on the rocks. So on behalf of Andy Lang, who is the property owner here, this is now all private property. So on behalf of Andy Lang and the University of Pittsburgh at Johnstown, the Geosciences and Environmental Science Department, which I'm a faculty member of, welcome to the New Paris Limestone Quarry. Up until about the year 2000, this was still in possession of New Enterprise Stone and Lime. It was a semi-active quarry. The limestone was mined as an aggregate rock. When it was being really actively mined back in the 70s and 80s and before that, it was famous for purple fluorite and fossils and the white calcite. And the New Enterprise Stone and Lime decided to sell it. The property owner that owns all the land around here ended up purchasing the property, and then working with us at Pitt Johnstown, we petitioned the state of Pennsylvania and the Fish and Game Commission, and we established this as a geoeducational site. So you're probably the 15th or 20th group that I've had in here since 2020 or 2021. We were kind of closed down a little bit during COVID, but Franklin County Rock and Mineral Club has been here. You've been here 3 or 4 times. A little bit about the geologic history. We want to go back in time about 420 million years to the middle Paleozoic era and the Silurian period. The Paleozoic era begins with the Cambrian period about 520 million years ago. Over the last billion years, the continents on the earth have come together and separated at least 3 or 4 times. And the most recent continental collision was Pangea, about 250 million years ago, into the Mesozoic era. All of the rocks here at this quarry predate Pangea by at least 200 million years. This is some really, really old stuff, but it's not the oldest stuff here in Pennsylvania. The rocks you're looking at here are on the order of about 420 to 415 million years old. We have a bunch of students at Pitt Johnstown that are currently involved in research here. We have volcanic ash layers here. I'll show you how they formed. The volcanic ash layers contain zircon crystals and elements that can be sent off to a lab and dated radiometrically. And one of our students at Pitt just presented at Geological Society of America. We're getting age dates for the rocks in the upper bench there that are about 415.5 million years. And that's very, very accurate. Okay, so let's go back in time to the late Silurian period, about 425 million years ago. 425 million years ago, and take my map with a grain of salt, it's just very general.
So this was equatorial?
Yes, 425 million years ago, the North American continent, which geologists refer to as Laurasia, was straddling the equator. And what would become the east coast of the North American continent and Pennsylvania, we were at least 30 degrees below the equator. I should have actually hung that down a little bit lower, but you have to realize this is just a snapshot in time over a process that extended for tens of millions of years. So 425 million years ago, the North American continent, along with the other continents, which I'm not showing on here, were at different positions on the Earth. This predates Pangea by at least 200 million years. What would become Pennsylvania is in a trough of water called the Appalachian Basin. Off to our east, there was a large landmass that no longer exists that we refer to as an exotic terrain. It was about the size of the country of Madagascar. The other continents are way over here, and I don't show them on the map. Asia, Africa, South America, Australia, India, they don't kind of enter into this picture. This large landmass off the east coast of North America is called Avalonia. And along the coast, a subduction zone opens up, which is a place where the crust of the earth is coming together, and one piece of crust dives back down into the mantle and is melted and reconsumed. So Avalon is being pushed towards the North American continent, which we call Laurasia. This is a cross-sectional view across the Appalachian Basin. So we're being approached by Avalonia. As Avalonia is pushed under the east coast of North America, we get melting on the descending plate. That magma rises through the crust, forms a series of volcanoes that we call a volcanic island arc. There are volcanic island arcs today. The Aleutian Islands are a volcanic island arc. Most of the islands in the Philippines and Indonesia are volcanic island arcs. Japan is a volcanic island arc. Lots of earthquakes, lots of volcanoes off the coast of the continent. Now, since North America was south of the equator, the prevailing winds between 30 south and the equator, the prevailing winds are from the southeast. The winds blow towards the northwest. So here's Avalonia being shoved towards the North American continent. We have a subduction zone below the Appalachian Basin. There are a long series of volcanoes that are off the east coast. As these volcanoes erupt, they're emitting enormous amounts of volcanic ash and dust. Because of the prevailing winds, that ash and dust is blown into the Appalachian Basin, settles out in between the rock layers, and we get layers of volcanic ash intermixed with the limestones here. Now, at the time this was happening, since we were at the equator and south of the equator, this was a shallow, tropical carbonate sea, similar to the Caribbean today. It was a carbonate reef, and on this reef, life was flourishing. Brachiopods, trilobites, corals, bryozoans, and a new discovery here in the Upper Silurian. Dean Rucco is supposed to be here.
He was supposed to be here.
But we had a high school student here a couple of years ago, and he discovered Eurypterids. So we have Eurypterids here today, and there's a photograph of some of the Eurypterids that Dean discovered on the second page at the bottom of the little fossil handout that I have up here on the table. So as Avalonia is approaching North America, the collision is imminent. This remains a tropical carbonate basin, and that's where these rocks are being deposited. Relatively shallow water, carbonate reef, sea level is rising and falling, but the water tends to be relatively clear and conducive to life. Eventually, Avalonia collides with the east coast of the United States. And if you drive north on I-95 up through Connecticut, Massachusetts, and into Maine, I-95, you're driving across Avalonia. There are still pieces of Avalonia that are fused to the North American continent. So eventually, the collision takes place, and here's where Pennsylvania is, and the red star is where you're located. So Pennsylvania would form, what would become Pennsylvania would be in this Appalachian Basin. So these rock layers in the quarry represent an ancient, warm, shallow, tropical sea. And I have printed out for you, this is called a stratigraphic column, and you're welcome to take one or two of these. If you didn't get one, you can come up and get one. But this is a representation of what the rock layers look like here in the quarry. So the bottom of the quarry is in the Upper Silurian period of the Lower Paleozoic era. We're back around 430, 425 million years ago. The first rock layer in the Upper Silurian is the Byers Island. It's down below us. You're not going to see that here, but I have it on the strat section because it underlies the Jersey Shore. Named after Jersey Shore, Pennsylvania, where it was first mapped, the Jersey Shore member of the Kaiser Formation. In geology, stratigraphers that map rock layers, large sections of rock layers that are thousands of feet in thickness are groups. Then groups are divided into formations, then formations are divided into members. So Stratigraphers find a way to make it real confusing for all of us. So the floor of the quarry, if you walk down this road, the floor of the quarry that's underneath all that rubble is Jersey Shore limestone. The Jersey Shore limestone is a massive dark gray limestone. It has fossil sponges in it called stromatotoporoids. It has some tabulate corals, brachiopods, bryozoans, crinoids. The Jersey Shore limestone was a reef. Picture a shallow tropical carbonate reef, a little bit deeper water. Then over time, the sea rose and came inland and the ocean became more shallow. And then we have the Laval member. The Laval member is everything that's in that first big high wall. And it's all the rubble, a big slope of rubble, which was all blasted down by New Enterprise stone and lime. The Laval is still a carbonate rock. It's thinly bedded, and it represents a shallow water tidal environment. The tide was coming in and going out and coming in and going out and depositing layers of limestone. In that shallow water, you had some fossils, and some of the pools in that shallow Laval limestone were hypersaline, super salty, like little trapped lagoons and bays. And that was the perfect environment for eurypterids, sea scorpions. I've been coming here to this quarry since 1984, collecting fossils and studying the geology. And it wasn't until Dean Rucco came here a couple of years ago, he contacted me online and said, "Hey, Mr. Lindberg, could I come to the quarry? Those rocks look amazingly similar to the rocks in upstate New York where I find eurypterids." And I said, "You can come, but there's no eurypterids here. I've been finding fossils, there's no eurypterids." So Dean Rucco gets here, starts climbing the rubble, and within 20 minutes he pulls out 5 or 6 eurypterids. So I'd eat my words. So he might be here today.
He did tell me he made like 4 pages of notes while he was doing that too. So
and I can show you where the eurypterids are found. They're in the top 4 or 5 feet below that first high wall. It's kind of difficult to get to. You've got to be careful. You need a really sharp eye to see them. We've not found any whole ones. We've only found heads and body segments and pieces of the claws. So
remember, don't go into the high wall.
We're
looking at the stuff that's already on the ground. We're not going into the high wall.
Right. Dean interprets these, and we're still studying them. Dean interprets these eurypterids as they are molted fragments because eurypterids, trilobites, are arthropods. Arthropods shed their shells. As they grow, the shells kind of fall out on the ocean floor and disarticulate, and then the pieces of shell get swept in and out by the tidal currents. So we're interpreting these pieces of eurypterids as... One of the organizations that I belong to is the National Association of Geoscience Teachers. It's a national organization. We're divided up into different regions. We're in the eastern section. I happen to be the president of the NAGT Eastern Section, and we just had our meeting 2 weekends ago in Erie, Pennsylvania. We have a number of awards that we give out every year. We award scholarships to students. We also recognize individuals that help promote geoscience education. One of our awards, and it's fittingly called the Digman Award. It's named after one of our former members whose last name was Digman. The Digman Award is unique to the Eastern Section, and it is presented to someone that brings geoscience education to the general public, who goes above and beyond the call of duty to educate people on the geological sciences, but that person is not necessarily a professional teacher or college professor. We've given this award to like museum curators and national park guides and state park guides, but I put Andrew's name in nomination earlier this year, and our Eastern Section Committee approved it. So it says the Digman Award, Eastern Section of NAGT, is presented to Andrew Dirtman Epic. I told him to put Rockhound, but they put Dirtman, so I told him if he wants another plaque made up. Honoring continued dedication to geoscience education 2025. So Andrew, on behalf of NAGT, here's your plaque and your award. Well done. So,
thank you all. This all started for me. I got the Each One Teach One award from the Eastern Federation, which now I'm the president of, and it kind of led to me teaching throughout the community. So now I'm teaching in Montour. I'm going to be doing some classes at Indian Steps, and actually this will be the first time anyone hears about this, but I just had long conversations on the phone with a producer at Maryland Public Television who wants to do a documentary on the history of the Chesapeake Bay and the Susquehanna River. She wants to film with me. So I said, what would you like to film? She said, you doing your thing. So I said, well, I'm bringing Geology Club with me, and you're all going to be on the show too. So keep your eye out for that. We're going to film that throughout this summer. So I want you all to be in it. I want to share it with everybody. So thank you all. Enjoy today, and thanks for coming.
Enjoy.